Hey Lily, you beat me here. How's it going? I think we're gonna give people a little bit of time. So let me just boot up a timer. All right, Lily, we're gonna give everybody about 6 minutes and give them a chance to join in. So I will be right. Well, let me mute myself for a bit, but I will be back. I'm gonna just post my previous stream to YouTube's. It would probably help if I unmuted myself before I ask how's it going. Those of you that can read lips. Today the plan is to do some more evaluating expressions with variables. So we are going to get to that in just a second. Okay. Checking to see if I have any email requests for problems. Apparently not. Okay. Bum, bum, bum. Just looking to see what we're going to start with. There we go. Okay, so right now what I'm looking at, here, I'll show you. So I'm looking at these quiz questions. These are the assignments for the algebra students for the week. Just getting prepped for more rigorous expression work. First one's looking pretty good. Where's the second one? The data from the second one. Ooh, much worse. Check this out. So we've got, okay, so this is what we're going to be talking about today. These problems where like no one is getting them right or some people are not getting right. So that is what this stream just became. Lily, unless you want to bring something else up, another topic, or in case I get someone to chime in via email or text or what have us. So that's where we are going. You know what? For some reason, I didn't have my chat open. Yes, I know. I posted that option that people can get in before me. So I guess that means you're in charge. You can run the lesson. Okay. Yeah, so we're gonna be talking about the same quiz right this very second. Okay. Let me zoom in and we'll start and we will begin with this one. So now I've assigned to everybody. It's a little, I mean, maybe not everyone gets the same questions, but the people that did get this question, not many people got it right. Okay. So let's look here. Okay, so we've got, so here's our expression, and it says that there are two answers. Okay. X plus X plus X plus 2. So my initial thought is just to simplify it. So this is 3X because they're being added together plus 2. So I know I like A because that's what 3X plus 2 is. 3 plus 2X, no. Okay, so what would this become? if this says 3 parentheses x plus 2, so if I distributed the 3 times both terms, that'd be 3x plus 6, which is not the answer. So that's not it. This one, if I do the distribution property, that'd be 2 times x and 2 times 1. So this would become 2x plus 2. And then it had an additional x right here on the back, so it'd be plus x. Oh, that'd make 3x. So combine like terms, so 2x and x makes 3x, so that'd be 3x plus 2. Okay. So I like D. And then 5x, no. So really, what does this come down to? It's asking, this is a combining like terms question. That's what this is. If you knew that x plus x plus x plus, Mr. Matthews talking, take 2. If you knew that x plus x plus x was 3x, and you knew that you can't mix that with the 2, and you know your distributive property, you'd be able to tell that the answers they're wanting are A and D. Yeah, A is one of them, and D would also work if you worked it out and instead to pick the 2 answers. So I'm wondering if some people got this one wrong because they only picked one, but I'm almost positive if you picked one answer and then you try to submit, it would tell you, hey, you're missing something. Let's try the next one. So in this case, 4 more people are missing it than getting it right. Okay. Yep. Like I just said on the previous problem, combining like terms is the goal here. Oh, excuse me. For some reason, I'm very yawny in my second stream of the day. Happens almost every day. Okay. Let's see what we can do. Well, I've got 2/5 m minus 4/5 minus 3/5 m. And really the key to this one is understanding that the like terms are here and here. The negative 4/5 is just going to get kind of stuck in this problem because it has no other terms to mix with. The reason that these 2 in the boxes work is they have the same variable to the same power. So 2/5 m minus 3/5 m, and now we have to dig deep for all of our integer skills and our fraction skills. This is 2/5. Yeah, there can be negative fractions. Yes, there absolutely can be negative fractions. So 2/5 minus 3/5 will be negative 1/5 m. And then this negative 4/5 is just kind of stuck. So 2/5 minus 3/5 will be negative 1/5 m, and then minus 4/5. It's right there. Let's look at the next one so many people had problems with. Okay. So again, what we're talking about here is combining like terms. So sometimes what I like to do is underline. So like right here, I've got negative 5c, and then I'll go ahead and underline plus 1.4c. And I won't underline the the numbers that don't have a variable. So now my eyes can focus a little bit. So what is negative 5.8 plus 1.4? I guess that is one step up in rigor when, oh no, they're decimals. Okay, well, of the two terms, the negative 5.8 has a greater magnitude. It's farther away from the origin. I know that I'm going to be subtracting their absolute value. So this is going to be 5.8 minus 1.4. But I know that in the end, my answer is going to be negative because of the magnitude of these values. I just have to do this real quick to get what that negative number is going to be. So a minus 4 is 4. Okay. So that's going to be negative 4.4 C. And now I need to deal with the whole number. I mean, the terms that don't have the C on them. So 4.2 minus 3.1. Model with mathematics. Attend to precision. 2 minus 1 is 1. 4 minus 3 is 1. So it'd be plus 1.1. There it is. Yeah. That's too bad more people are missing that one than getting that one right. Let's look at the next one. Aha. So we're trying to find equal expressions, but we need to pick all that apply. I'm wondering if people miss these because they don't pick all of them. Let's see. Okay, well, my first instinct is to just combine everything up here that I can. So z plus 6, that would be 2z plus 6. Anything that's equivalent to that. So the problem with A is I've got 1, 2, 3 z's. So this is 3z plus 6. So I know it can't be A. B would end up being z plus 12. So now my brain's starting to worry. So if we do the distributive property here, that means I need to multiply 2 by both terms. That'd be 2 times z would be 2z. And 2 times 3 is 6. So, yeah, I like that. Ooh, it lets me do those stamps. How fun. Okay, so I would only pick C for this. The other two just don't match up. Let's look at the next one that so many people are struggling with for some reason. Ooh, a goose egg. Okay, so everybody that's watching this on YouTube later, out of the 4 students got this one, nobody got it right. Nobody. So please look. Please pay attention. Let's see. Let's go with. Yes, we gotta go with red. This one was so rough. What are we being asked to do? We're being asked to combine like terms to create an equivalent expression, and this is the expression we were given. Okay. Well, I guess I have to distribute this 20 onto both terms because that's what the distributive property says to do. So what would be 20 times 1.5, or rather a negative 1.5? Well, 1.5 times the 10 would be 15 times 2 be 30. So I'm guessing that'd be negative 30r. My little number talk moment here was that, okay, in my brain powers, I was trying to do this. I was trying to do 20 times negative 1.5 r. And the way I thought about it was, okay, well, that'd be the same as 2 times 10 times a negative 1.5 r. And then I thought, well, 10 times 1.5 r would be 15r. And then 2 times 15r, oh, sorry, negative 15r. And then 2 times negative 15r will be negative 30r. That is where my number talk brain went with that. Okay. So that's negative 30r. And then 20 times 75 hundredths. How does my brain want to handle that? Trying to do this in my head. 20 times 0.75. Well, I'm trying to be clever and break this down. Okay. So if I'm doing 20 times 75 hundredths, and I did something similar to what I just did, what if I said this was 2 times 10 times 75 hundredths? What if I did the 2 first? That'd be 10 times buck 50. 2 times 75 hundredths is 1.5. And then 10 times that would be, move the decimal over, so it'd be 15. So negative 30r plus 15? Oh, that is a. Oh, wait. I'm checkboxing. Oh, don't do that, Mr. Matthews. Don't do that. I agree. Okay, so there must be another answer here somewhere. Unless I goofed, which is totally possible. And you really only want to goof on camera on YouTube, right? Hmm. Hang on. Yeah, I might have to do that. But one second, I wanna. If this were me, like if I'm trying to put myself in your shoes. If this was my moment, and I said, okay, wait a minute, get rid of that. Because if these are my options, and I don't like any of them, I gotta think. Okay, now wait a minute. I wonder. Like me just thinking if this was my assignment, based on my work, I don't think it's this. Don't think it's this. I don't think it's this. But this one's written in a really peculiar way. I'm wondering if this comes out to be the same. So negative 15 times 2r, that's negative 30r. And negative 15 times negative 1 would be plus 15. Aha. So here's what the sneaky person did when they wrote this problem. That should be the right answer. You know, it says 0 people got it. That's weird. So I will click reveal the answer here in a second. -20. Yeah, that should be okay. That's okay. So I'm just gonna say that that's what my answer would be because it seems to make sense. Oh, there must have been another option I couldn't see when I was so zoomed out. Hang on. Oh, I get it. Okay, okay. So in this teacher view, it's showing the options that people picked. Oh, you know what? And I think in the work I just did, I did 11 plus 15. I think I would submit an issue with that. -15. That says -15. Maybe -30 R. I like this one. Maybe it looks different in the teacher in the student view rather than mine because that seems to be an equivalent expression. Here, I guess I'm trying to construct. I'm trying to argue my way out of it. So this and this. -15 times 2R be -30R. And then -15 is -1 would be +15. So yeah, I would actually say that is an equivalent. I have issues with you, question number 50. You type so there are no options. What do you mean? Gotcha. Aha, I see what you mean. I guess I feel bad because the one student, who is this? Ah, okay, so I would actually argue that Caleb did just fine because it said combine like terms to create an equivalent expression. I guess it's hammering him because he didn't combine everything. Okay. So that's why he didn't get credit. So if the directions only said create an equivalent expression, he would have gotten points because technically he's right. The problem is it says combine like terms, which means you've got to mix everything that you can together, and he did not. So yeah, this is the answer he should have gotten. Okay. Thanks for clarifying why those are not multiple choice answers. That's what people typed in. Thanks for that. Okay. Here's another one. So this must be another thing that people typed in. Okay. What is you? I'm old. Oh, you're welcome. You're welcome. Me so clever. Okay, so of the three people that attempted this one, nobody entered anything that was technically correct. Let's see what the directions say to do. It says here to combine like terms. And then it went on to say, simplify the coefficients of those numbers in front of your variables. And constants. And when it says constant, that just means the numbers that are just like left out with no variables. Those are constants. Okay. Well, let's see what we can combine and what we can't. So we've got a negative 6/5 minus 2/3 v plus 4/15 plus 1/3 v. So that means, if my eyes don't deceive me, the negative 6/5 is a constant. The 4/15 is a constant. The negative 2/3 v and the 1/3 v, those are going to be like terms because they both have a v to the first power. I'm going to go ahead and do these with the variables first. So negative 2/3 plus 1/3. Okay, so if I'm down 2/3 and I add a third, I'll be going up. So I'm going to end up at negative 1/3 v. If I was negative 2/3 and then I went up 1/3, I'd be negative 1/3 v. And then negative 6/5 plus, oh, common denominators. Okay, I guess this I could change to 15ths pretty easily. So 5 times 3, 6 times 3, so it'd be 18. So negative, okay, keep in mind that's negative 18/15 plus 4/15. So we end up at negative 4/15. Because, no, I'm sorry, negative 14/15. Because 18 is, the negative 18 is way more potent. It has a greater magnitude than 4. So negative 4/15. And that is all that can be done as far as I can tell. Negative 1/3 v minus 14/15. Yeah. I mean, once you get the hang of leaving expressions like this, like, well, stuff the more you could do. It feels kind of nice because you don't have to do any more explicit, precise mathematics. You just have to get as far as it'll go. Okay. Well, we got about 10 minutes left. I wish I could let you click through these and be like, oh, do this one, do this one, do this one. But it looks like people are having trouble kind of all over the place with these. And they're all just combining late terms. This one looks pretty juicy, though. Yeah, we'll try this one. I'm going to zoom in a little bit. Yeah, I like it. No, this is pretty sweet. I think that I'm lucky and that mathematics really lends itself to this sort of problem by problem, practice by practice. And if you couldn't make it, check it on YouTube later sort of situation. As long as everyone commits to doing their work, that is what remains to be seen. There's a lot of people that have not submitted anything yet, and that might just be because their plan is to do it tonight and tomorrow. So we will see. Okay, the first thing we got to do is do the distributed property. So I've got to do, and I just don't like that color. Okay, so I've got to do -4 times both terms on the inside, and then I have to do -3 times both terms on the inside. It's really important in this case that everyone understands you have to do the negative as well. It's -4 times both. It's -3 times both. Okay, so digging deep into our integer skills, -4 times negative 11 is positive 44. Negative 4 times positive 4n will be negative 16n. Negative 3 times a negative 2 will be positive 6n. And then negative 3 times a positive 9 will be negative 27. Okay, so now we very carefully look around and we say, okay, well, I've got a 44 and a negative 27. Those are the constants. Oh, the page errored out, but it's fine. I still have the problem. And I got a negative 16n plus 6n. That the same variable. So, okay, so 44 minus 27. I'm going to do some borrowing. 14 minus 7 is 7. 3 minus 2 is 1. So I know I'm going to be adding 17 onto the back of this. Negative 16n. Okay, so negative 16 plus 6. So if I was down 16 and I came up 6, I'd be at negative 10. So negative 10n plus 17. And that's as far as it's going to go. I can't mix it past that. Okay. Combining like terms, giving a surprising number of people issues. Okay. Maybe I'll stop it there. Yeah, I think that's just the sign to call it. But it's been a pretty good session. So I think we've gotten through a lot of combining like terms and little common nuances. Yeah. It's all right. It's all right. So for everyone watching on YouTube, just remember that I think you get a second attempt at the quizzes that are the con grades for Algebra 1 this week. You can get in contact me to confirm or disconfirm that. Please look at all the content that I'm putting up for extra practice. And, take care of yourselves. It's a beautiful day. It looks pretty outside. The social distancing is in place. And even though we have the secure and safety protocol, you're still allowed to go outside. Just stay 6 feet away from everybody. So take care of your families, take care of yourselves, make your beds. Every good day starts with a made bed. And I'll look forward to seeing you guys next time. Bye.